Yes, you are.
Yeah. So let us start session. The last class. Yes, that introduction. Introduction to software, like system software, application software. So discussed. Java is application software, right? Java is application software. Next, about OS. Also discussed. Yeah, the software basics. Okay. Yes, next, Java functional backend software. Java here backend. Okay. Next, low level language, high level languages. Java is language. Java is language in the low level, high level languages. Low level, high level languages. Low level, it's a system understandable language. It is in the form of binary code. Yes, it is called as machine language. It is called as machine language. High level language, it's user understandable language, like English language. Yes, Java is a high level language. Java is a C, C++, Java, and all these high level languages. Okay, fine. Yes, here high level language to binary code. C, C++, Java, and all their high level languages. Okay, these high level languages have to convert into binary code. Yeah, last class session, right? Yes, Java, C, C++, Python, these are all are high level languages. Yes, like a yes, high level language, it's a user understandable. Yes, it's like English language, looks like English language, Java, C, C++, and Python, all their high level languages. Right? So every high level language program has to convert into binary code. A system understandable language. That should be converted. How to convert? For these compilers or interpreters. Compilers or interpreters converting from high level language to binary code. Right? Yes. Today topic is about compilers and interpreters. Today topic is about interpreter and compiler. That is, let me explain. Yes, interpreter versus compiler. Topic is, see, interpreter, compiler, both are converting from high level language to binary code. But some difference is there. Yes, what's the difference between interpreter and compiler? Let me explain. Yes, interpreter versus compiler. So both are to convert from high level language to binary code. But some difference is there. So what's the difference between interpreter and compiler? So today topic is about interpreter and compilers. First, let us see about interpreter. Yes, about interpreter. Yes, for interpreter, I'm taking Python. So Python is a best example for the interpreter. Python is a interpreter-based language. Python is a interpreter-based language. Yes. So for example, test program. Yes. Python. Taking some Python examples. So D drive, test folder. Yes. Simple Python script. Just I'm writing very simple Python script. Just I'm writing very simple Python script. D drive test. In this, I'm writing simple Python script. CMD, command prompt, command prompt. Yes, command prompt. Yes, go to D drive, D colon. That will take to D drive, right? CLS, clear the screen. Now contents of D drive, DER shows the contents of D drive. So these all are D drive contents here. Okay, DER means directory. These all are directories. So these all are directories, right? See names starting with MN Rao, all directories. All these are directories. See D drive. See all folders, right? MN Rao, Java, and all these are folders, right? Folder directory both are same, no difference. Yes, in GUI it's a folder. Yes, it's a graphical user interface. In GUI it's a folder. So GUI it's a folder. In GUI calling as folder, same thing is a directory. Directory folder both are same. Okay. See this D drive. Yes, all the folders. Same thing here, same names here, directories. See, I'm repeating once again. Yes, topic. Today topic, interpreter versus compiler. Topic is about interpreter and compiler, right? Yes. See, yesterday discussed about different low-level language, high-level language. High-level language to binary code. Yes. Compiler or interpreters. Compiler or interpreter converting from high-level language to binary code. Compilers or interpreters converting from high-level language to binary code. A Java program to binary code, C and C++ to binary code, Python to binary code. So these are high-level languages. High-level language to binary code. High-level language to binary code. For this, either compiler or interpreter. So today topic is about interpreter versus compiler. Yes, anyone have the idea about interpreter and compilers? At least one point. Suppose who are already working. Yes, any idea? Of course, I'll explain very clearly. Yes, interpreter compiler differences. Okay, let me explain. For interpreter, I'm taking Python. Python is the best example for the interpreter. Python. So I'm taking some Python scripting. Yes, using Notepad. See, D drive, so test folder. So here I'm developing Python script, simple Python script using Notepad. Python script using Notepad. Okay. Yes. So D drive test. Yes. First is CMD command prompt. CMD command prompt. Yes. Here go to D drive. D colon. It's a D drive, right? D colon that will take to D drive. Now check the contents of D drive. DER. To check the contents of directory. So to check the contents of directory, see DER means directory. See all are directories. See directory. All are directories. Right? Yes, same thing at D drive. I'm opening D drive. See all are folders, right? Same names. MN Rao. All are starting with MN Rao. You folder. Same thing, directories. Directory folder both are same. Okay. So this is GUI. In GUI calling as folder. In GUI it's a folder. In character interface directory. Both are same. Both are same. Now D drive. Yes, test folder. D drive test folder. Yes, at the command prompt. Now we should go to test directory. Change of directory. CD test changed. CLS clear the screen. Okay, CD means change of directory. Now we are in test directory. D drive test. So we are at test directory. 0 files. DER to check the contents. DAR CLS clear the screen. DIR to check the contents. 0 files. Okay, see that this folder is empty, right? This folder is empty. That's it. Now let us start writing simple Python script. Notepad using Notepad. Notepad. Yes. Test.py. Notepad. Test.py, right? Notepad. Yes. .py is the extension. Yes. Open, right? Do you want to create new file? Yes. Yes. Very simple script here. Addition, subtraction, and multiplication of two numbers. Addition, subtraction, multiplication of two numbers. Yes, A is equal to 10. Suppose B is equal to 20. Suppose C equal to A plus B. A plus B. Print. Print. Yes, addition. Yes, addition is equal to displaying C value. So addition, displaying addition, right? Yes, next. C is equal to, yes, A minus B. C equal to A minus B. A minus B. Yes, print. Print. Yes, subtraction. Subtraction. Subtraction equal to. Yes, Python also I have a very good experience. Python, Java, Linux, databases, very good experience. C equal to, yes, A into B. Right? Print. Yes. Subtraction next multiplication. Yes, multiplication is equal to comma series. So this is simple Python script. So adding two numbers, next subtracting the two numbers, next multiplication of two numbers, right? So this is very simple script. Yes, addition, subtraction, and multiplication of two numbers. Okay. Yes. Save it. Yes. Command prompt. dir, check it. So this is Python script, right? Just now created. Okay. Yes. CLS, clear the screen. dir, now run it. Python. Yes. Test.py. Yes. Addition, subtraction, multiplication. Got it, right? Addition, subtraction, multiplication. Okay. The script executed directly here. So here. So Python test.py. So Python, this is interpreter. Python interpreter to run the Python script. It is a Python interpreter to run the Python script. Yes, how this interpreter is working. That is how this interpreter is working. See, here successfully completed. Program successfully completed. Suppose any errors, what happens here? Any error. See, I am using up arrow key. Up arrow key to get the previous commands. Up arrow key. Up arrow key. So notepad test.py. Suppose some mistakes. For example, here W code is missing. W code is missing. Okay, right? Suppose here bracket missing. Bracket missing. Okay, suppose here comma missing. What happens? Yes, there are three errors. So first one, next one, next, totally three errors in the program. Save it. Now go to command prompt. Now run it here. Yes, yes. dir, check it here. CLS, dir, check it. 2031, just modify, right? Time stamp. Yes, let us run it here. Python test.py, right? Run it here. See this. Seventh line error. Showing error at seventh line, right? But actually there are three errors. Yes, in script three errors are there. In script three errors, but showing only one error. Only one error. Reason. I'll explain. How that interpreter is working. Okay, how that interpreter is working. Yes, maybe Python interpreter or any interpreter. Yes, same working is same. Python interpreter or HTML interpreter, maybe shell scripting interpreter, PHP interpreter, Perl scripting, JavaScript, like this. There are many interpreter-based languages. All are working same. Yes, let me explain clearly how it's working here. So first of all, interpreter checks the first statement. If first statement is correct, then check the second statement. Second statement also correct, then checking third statement. Third is also correct, then checking next statement. Suppose something wrong here, simply stops. Yes, interpreter stops. If any error comes, interpreter stops. It won't check rest of the code. It won't check rest of the code. Any error comes, simply interpreter stops. Interpreter checks the code line by line. First line checking if it is okay. Next line checking if it is okay. Next line. Suppose something wrong, simply stops. Yes, any error comes, interpreter stops. Interpreter checks the yes line by line. Interpreter checks the code line by line. Line by line. Suppose any error comes, stops. So interpreter shows only one error. It shows only one error. Let us correct the mistake here. Seventh line error. Yes, notepad tested. Seventh line. So you get W code is missing, right? Seventh line W code missing. Yes, save it. Correction is done. Save it. Next, back to command prompt. CLS. So dir. Now run it once again. See. Time again modified, right? 2033. Time of modification is. Yes, Python. Yes. Run it here. See this. Now 11th line error. So next error 11th, right? So this showing only one error, not showing all the errors. Now 11th line. Yes, let us correct that mistake here. 11th line error. So 11th line. So this is bracket, right? Save it. Save it. Save it. Now go back to this. Yes, now run it here. Yes, see this. Now 15th line error. So 15th line error, right? 15th line error. So 15th line. Now correct that mistake. 15th line. Here comma missing, right? Comma missing. Save it. After saving, now run it. Run it here. Yes, working fine. So interpreter checks the code line by line. Maybe Python interpreter or HTML interpreter, any interpreter working is same here. Any interpreter working is same. Interpreter checks the code line by line. If any error comes, simply stops. Any error comes, stops. It won't check for rest of the code. It won't check for rest of the code. Any error comes, simply stops. Any error, simply stops. Okay. 1 second. Okay. So any error comes, simply stops. Suppose if no error, then what happens? Suppose everything is fine. Suppose this statement is correct. Let us say this is correct. And this one is correct. And this one is correct. Yes, next this one is correct. So if every statement is correct, then what happens here? Then execution starts. If everything is fine, then execution starts. How? So first line. So this first line converting to binary format. Interpreter converts the first statement into binary format, zeros ones format. If this binary format given to processor, so processor taking that code, generating output simply. Processor taking that code, generating output. So first line completed. Okay. So interpreter is converting first line into binary format that will be given to processor. So generating output, right? Yes. Next statement, converting binary format. Okay. Yes. Simply that will be given to processor. So processor generating output simply. Generating output, right? Okay. Like this next statement. Like this line by line converting. So next statement converting. Okay. Yes, that will be given to processor. Same thing happens here. Processor, right? Now processor generating output like this. So what is happening here? Interpreter is checking line by line. Is not as checking even executioners line by line. First line converting to binary code and given to processor generating output. Second line converts into binary format, given to processor generating output. Next line converts into binary format and given to processor generating output, right? See, this binary code will not store anywhere. This binary format will not store anywhere. So interpreter converting code line by line, converting code line by line and generating output, converting generating output. That's but here, sorry, yes, but this binary code will not store anywhere. The binary code not storing anywhere. So this working of interpreter. So working of interpreter is like this. Now let us see compiler. Yes, how compiler is working? Compiler. Yes, compiler. Let us see compiler. For compiler, I'm taking C program. Some test.c. C program. Okay. Yes, I'm taking C program. Yes, C program. Just I'm taking some C program. Yes. Yes, Windows based Turbo C. C programming. See, my beginning career started with C language only. My beginning career, yes, first 3 years of career C language. Later switched to Java. First initially embedded C. Later switched to Java. C program. Yes, you guys, can you see my screen here? The blue screen. I think just ID changed here. Can you see my blue screen? Hello. Yeah. So now this is C program. I hope everyone able to see this screen here. C program. C program. Same example. Same example here. Yes, ABC 3 variables. Yes, enter first number, enter second number. Yes, addition, subtraction, multiplication. Same program. Same thing, C language. Addition, subtraction, multiplication of two numbers. Addition, subtraction, multiplication of two numbers. Okay, same example. Yes, compiling. Success, no errors. See, warnings 0, errors 0. Press any key. Right? Yes, now run it here. Run the program. Yes, run it. Run it. Yes, output. Enter first number 10. Next number 20. 1 second. Yes. So got the output, right? Okay. Yes, addition, subtraction, multiplication of two numbers. Right? Yes. See, compile, no error, run it. Yes, first number 10, next number 20. Addition, subtraction, multiplication of two numbers. Got it right? Suppose any errors, what happens here? Suppose some mistake. Suppose here semicolon missing. Semicolon missing. Okay. Suppose here, suppose maybe some double quotation missing. Suppose here, yes, semicolon missing. Suppose in scanner, suppose comma missing. Okay. Yes, here. Yes, maybe some printf, some bracket missing. Suppose here some semicolon missing. Yes, here gets here some bracket missing. Yes, what happens here? See, save. Once program modified, we should save it. Saved. Now let us compile it. Compare it. See that? Yes, errors. There are 10 errors totally here. So 10 errors. Press any key. Yes, this is showing all the errors from top to bottom. So compiler, see this. Look at the bottom. 7th line error. Next 11th line error. 17th line. 19th line. 21st line. 29th line. 31st. All the errors from top to bottom. All the errors from top to bottom. So compiler checks the code from top to bottom. Compiler. Yes, how it's working. Let me explain. Compiler. How that compile is working. Let us, these are C program statements. First statement. Yes, just imagine like a C program. This is first statement, next statement, next statement. There are some statements like this. Okay. Next statement like this. Yes, how it's working here. So first of all, compiler checking first line. If it is correct, then it checks next line. Next line also correct. Then checking next line. Suppose something wrong. Error at some line. Error at some line. And then checking for next line. Next line also correct. Next checking next line. Okay. Yes. Suppose any error. Error at some line, right? Yes, even error comes. Compiler go to next statement also. In case of interpreter, what happens here? Any error comes, stops. Any error, interpreter stops. But compile is not like that here. Compiler checks the whole code from top to bottom. Compiler checks whole code from top to bottom. Even error comes, it go to next statement. So next statement. So checking whole code from top to bottom shows all the errors. Compiler checks the whole code from top to bottom and shows all errors in the program. Shows all the errors, right? Let us correct all that mistakes here. Let us correct that mistakes here. Yes. Yes. Suppose here, yeah, here semicolon missing. Yes. Suppose here double quotation missing. Some statements here I'm correcting here. Here semicolon missing. Okay, next here bracket missing. Bracket missing. So once modified, save it. Saved. Overwrite. Do you want to overwrite? Yes. Now compile. Still two more errors. Still two more errors. Enter key, right? Yes, two more. So here comma missing. Comma missing here. And next, yes. Okay, yes. Print here. Bracket missing. Right? Now save it. Saved. Yes, overwrite. Yes. Say yes. Now recompile. Yes. Still one more error. So here, yeah, here semicolon missing. Print statement. Semicolon missing here. Semicolon missing. Semicolon. That semicolon. Yes. Save it. Yes. Overwrite. Yes. Now compile. Recompile. Success. Success, right? Success. Yes, after success. Yes. Now run it here. Run it. Yes. First number 10, next number 20. So got it, right? Okay, so when you run it here, what happens here? If no errors, what happens? What is next step here? Let me explain clearly. Suppose no errors. Everything is fine. What happens here? Suppose everything is fine. Top to bottom. Yes. Everything is fine. No errors. So top to bottom, all the statements, everything is done. If no errors, then what happens here? If no errors, then compiler opens one more file. So compiler opening one more file. See test.c, right? Here is a test.c. So compiler opens one more file. After opening one more file, yes, now compiler converts that whole code into binary format. So first line converts into binary format and write to another file. Yeah, this file is a exe file. Test.exe file. Test.exe file generates. See previously interpreter. So first line converting, immediately executing. Second line converting, giving output. Next line converting, giving output, but not storing anywhere. This binary format will not store anywhere. Binary format will not store anywhere. That is the case of interpreter. Interpreter, that binary code is not storing anywhere. But in case of compiler, this whole code converts into binary format. That whole code converts into binary format. That whole code converts into binary format. That binary format write to another file called as exe file. So zeros ones format, right? So next line converts into the zeros ones form binary format, converting into binary format. Okay, converting into binary format and write to another file. That file is exe file. Exe means executable file. Yes, exe means executable file. So that whole code converts into binary format, right? Binary format. Okay, generating exe file like this. After generating exe file, now this exe file given to processor. So processor, right? Now processor taking that exe file, simply generating output simply. Executing, generating output simply. Okay, right? So compiler checks the whole code from top to bottom. Compiler checks the whole code from top to bottom. If no errors, generating that exe file. Exe file is a binary code file. It's a system understandable language. System understandable language. That exe file given to processor. So processor taking that exe file and executing at a time, all lines at a time and giving output. So this is working of compiler. Let me show that exe file. See, this is your program, right? Background of this one, C drive, background. See, it's ID, C language ID, behind of this C drive. Yes, TC. Turbo is here installed here, TC, bin folder. So here program. The test program. What is the name of the program? Test.cpp. CPP means C++. Same compiler using for C language also. C++, C language compiler both are same. C++ compiler using for C also. Right? Test.cpp. Let us go to the test.cpp. See, this is program test.cpp. Let me open that. See, that's your program, right? C program, main, ABC, yes, clear screen, yes, printf, scanf, gets, yes, same that program, right? Yes, open backend, right? That is your C program. C program, right? C program. Okay. Not test. No, that related programs, let me delete. Test. Yes. See, test.cpp, right? Test.cpp. See, this program simply I'm compiling. Just compiling. Compiled. Success. No error. Success, no error, right? Now, run it. I'm running. So when I try to run it here, before going to run it, it creates one exe file. So behind of this creating one exe file, just observe it here, run it, see this. Yes, exe file created. Test.exe just now created. Time 2048. Just now created. Right click, check the properties. Show more on, sorry, properties. .exe file, right? Test. It's .exe file created. .exe file created, then executing, right? .exe file created. See, 10, 20, right? So got the output. So what happens here? See, I'm deleting once again. This is exe file deleted. Deleted. Yes, again, run it here. See that. Yes, again that exe created. Again that exe file created. So again exe file created. So here first number 10, next number 20. Yes, got it, right? That's it. Okay. So this is working of compiler. So compiler checks the whole code from top to bottom. If no errors, generates exe file. That whole code converts into binary format, writing to another file called as exe file. So compiler generating exe file. That exe file given to processor generating output, right? Now see the difference here. Interpreter, that code directly executing, not generating any exe file. So this code not storing anywhere. The binary format not storing anywhere, directly executing. But in case of compiler, the binary format storing into one file called as exe file. Exe means executable file. Exe means executable file. Okay, fine. Now let us see the differences here. Compiler interpreter differences. Let me explain step by step. Let me compare this. Interpreter and compiler. Yes, interpreter compiler the differences. Yes, interpreter, next compiler. Interpreter and compiler. So what's the difference between these two? So first one, yes, interpreter. It checks the code line by line. It checks the code line by line. So interpreter checks the code line by line. Yes, when come to compiler, it checks whole code from top to bottom. Compiler, yes, it checks whole code from top to bottom, from top to bottom, from top to bottom, from top to bottom, right? Yes, interpreter checks the code line by line. Interpreter checks the code line by line. Compiler, it checks whole code from top to bottom, whole code from top to bottom, right? Next, yes, execution. It executes code line by line, line by line. So checking and execution both are line by line, but compiler at a time. It executes code at a time because exe file, right? Creating exe file and executing at a time. Yes, it executes. It executes code at a time, right? Yes, at a time. At a time, right? Yes, next. See, interpreter. If any error comes, stops. Okay, if any, yes, if any error, yes, if any error comes, it stops. Yes, if any error comes, it stops. It stops, right? Stops. Okay. So hence it shows only one error. Hence it shows only one error, right? Only one error. Yes, it won't show all the errors. If any error comes, stops. If any error comes, stops. Hence it shows only one error. Compiler. Compiler. Yes, it shows all the errors from top to bottom. Checking top to bottom, right? Yes, it shows all the errors from top to bottom. It shows all the errors. Yes, all the errors from, yes, top to bottom, from top to bottom, from top to bottom. All the errors from top to bottom. Right? Yes, interpreter. Yes, if any error comes, stops. So it shows only one error. Compiler. It shows all the errors from top to bottom. Right? Next, most important difference, exe file. Most important one. Interpreter, compiler, main difference, exe file. Yes, interpreter. It does not generate exe file. Does not. Yes, it does not generate. It does not generate exe file. It does not generate exe file. Interpreter never generating exe file. Yes, compiler, it generates exe file. It generates exe file. Compiler generates exe file. Okay. Interpreter, it does not generate exe file. Compiler, yes, it does not generate exe file. Compiler generates exe. Next, one more difference here. See, interpreter. So here, no exe file, right? Interpreter, no exe file. Directly executing source code. Code executing directly. No exe file. That code executing directly. So this is called a source code. That English language, high level language program. This high level language. This code is a source code. Interpreter executes source code directly. Interpreter executes source code directly. Yes, it executes. Executes. It executes source code directly. It executes source code directly. Right? It executes source code directly. Right? Yes, in case of compiler, what happens here? It generates exe file and executes. Yes, it executes exe file. Now it generates exe file and executes. It executes exe file. It executes exe file. Okay, interpreter, yes, does not generating exe file, but compiler generates one exe file. Yes, interpreter, it executes source code directly. Yes, compiler, it executes exe file. Right? See, interpreter-based languages, these are called as scripting languages. So these are called as scripting languages. So these are called as scripting languages. So these are called as scripting languages. Yes, compiler-based called as programming languages. So these are programming languages. Programming languages. See, scripting language, programming language, there is a difference. Scripting language, interpreter. All interpreter-based languages are calling as scripting languages. Scripting programming is not same. Don't think both are same. Scripting is different, programming is different here. Okay. Yes, all interpreter-based languages are scripting languages. Yes, all compiler-based programming languages. So scripting language, programming language, one more difference. Scripting language, that is open source. Always source code only. But programming language, no source code. Source code converts into exe file like exe format. Finally, that file is exe formatted. But when it comes to scripting language, directly source code executing. Okay. So these are kind of scripting languages, compiler-based and programming languages. Okay. Yes. Scripting language examples. Examples, Python. Python is the best example of scripting language. Python, HTML. HTML also interpreter-based language. JavaScript. JavaScript also interpreter-based language. JavaScript is not a Java. JavaScript different, Java different. JavaScript different, Java different here. See, JavaScript and Java. That point, I think previous session is, see, this is the application, right? JavaScript comes here, front end. JavaScript is a client-side language. Front end means client. JavaScript using at the client-side validations. JavaScript using at the client-side validations. Yes, Java at the server side. Server-side transactions. JavaScript using at the client side, Java using at the server side transactions. Okay. So JavaScript and Java both are not same. Different. JavaScript different, Java different here. JavaScript, it's a browser understandable language. A JavaScript running in the browser environment, it's a browser understandable language. Java is a JVM understandable language. Java is a JVM understandable language. JavaScript working at the client side, yes, Java working at the server side, backend. Next, JavaScript is a browser understandable language. Java is a JVM understandable language. Okay, fine. So JavaScript, Java, not same, different kind of things. Okay, fine. JavaScript. Yes, next, PHP scripting, very old language. PHP scripting, whole scripting, very old language. Next, Linux shell scripting. Shell scripting, of course, old language, but in use here. Shell scripting more useful. This is in real time. Yes, in many projects using shell scripting. Okay, so Python, HTML, JavaScript, PHP, Perl, and shell scripting, right? See, in these languages, no exe file. HTML, no exe file. JavaScript, no exe file. So these languages don't have exe file. Don't have exe file. Okay, right? Yes, programming language examples. Just not discussed. C and C++, right? C and C++. C, C++. Next, C sharp. Yes, .NET, C sharp, right? C sharp. Okay, these are programming language examples here. So these are, yes, scripting language, interpreter-based examples. Interpreter-based examples. So these are compiler-based examples. Okay, fine. So here finally come to some conclusion here. So interpreter-based language don't have exe file, right? Yes, interpreter. See, interpreter-based language. Interpreter-based language, yes, don't have exe files. Interpreter-based language don't have exe files. Okay, don't have exe file. Yes, compiler-based language, finally generating exe file. Always it's exe file. So finally getting exe file. Finally generates exe file. Okay, finally generates exe file. Okay, interpreter-based language don't have exe file concept here. Interpreter-based language don't have exe file. Yes, compiler finally getting exe file. So this is difference. I hope you understand, guys. Interpreter and compiler. So interpreter checks the code line by line. Compiler whole code from top to bottom. Next execution line by line. But compiler at a time can. Yes, here main difference exe file. So this is main difference. Interpreter does not generate exe file. Compiler generates exe file. Interpreter executes source code directly, but compiler exe file. Next, one more thing. Interpreter shows only one error, right? Interpreter is only one error. Interpreter only one error. But compiler all the errors from top to bottom. So this is difference. Interpreter and compiler. Okay, fine, well and good. Yes, maybe doubt here. See, trainer, Mr. M.N. Rao, explaining everything, fine. Okay, talking about C, C++, C Sharp, HTML, Python. Where is Java? Our course Java, right? Java. But he's not talking about Java. Yes, 100% getting the doubt, right? Sure. Where is Java? Yes, is it interpreter based or compiler based? So what is Java? Now let us start Java here. Yes, I'm starting now Java. Yes, today starting Java introduction. Java. Yes, question is Java compiler based or interpreter based? That is question. Yes, Java. Is Java compiler based or interpreter based? Yes, answer. Yes, anyone? Anyone? Can you answer this? Java compiler based or interpreter based? Anyone?
Compiler based.
Compiler based. Yeah, who is that? Seenam Khana.
Yes.
Yeah, compiler based. Next, any others? Java is a compiler based. Next. Others.
Both. It considered both.
Vanilla. So vanilla saying that.
Vanilla.
Yeah, vanilla both. Next. Next, anyone? Okay, I will explain how Java is working. I'll explain first of all. Okay, after explaining, just you decide it. I'll explain. You decide it. Yes, Arshad saying that compiler based. Okay. First, let me explain. Let me finish topic. Then you decide. Let us start. See, except Java. Except Java. Except Java. In other languages, what happens? Except Java, in other languages, maybe C language or C++, Python, something like this. Sorry. Except Java in other languages. So in other languages here, what happens here? Except Java in other languages, what happens here? So first of all, source code. So first of all, source code. The source code converts into binary format. Binary code. Just now I showed, right? Source code converts into binary code. This binary code given to processor. So processor taking that code, generating output simply. So this is what is happening with other language except Java. Except Java. Except Java in other language, maybe C language or C++, Python, something like this. Source code converting to binary code. Okay, maybe compiler or interpreter. Suppose C programming, compiler converts the source code to binary code. Suppose if it is Python, interpreter converts source code to binary code, right? So this is what is happening with other languages. Yes, come to Java. Yes, in Java. In Java, what happens? Java. So first of all, source code. Source code converts into byte code. Byte code. That byte code converts into binary code. Byte code converts into binary code. That binary code given to processor. So processor executes generating output. Generating output. So finally getting output, right? Yeah, there are two steps in Java. Java, two steps. Source code to byte code. Next, byte code to binary code. In Java, byte code what introduced here? That intermediate code, byte code introduced. Reason to make it as independent of platform. So why bytecode concept introduced in Java? To make it as independent of platform. Yes, that independent of platform topic next we'll discuss. Wait, I'll explain. Yes, maybe next session maybe getting. How if Java is independent of platform, next session I'll explain. Just wait. Source code to byte code to binary code. So you can first step, source code to byte code. Yes, this part by the Java compiler. Yes, Java compiler. So this part by the Java compiler. Okay, Java compiler. So this is by the Java compiler. Right? Source code to byte code by the Java compiler. Next, byte code to binary code. Second part by Java interpreter. Second part by the Java interpreter. Java interpreter. Java interpreter. Let me show practically compiler interpreter. Yes, let me show that. Yes. So Java example for this taking notepad. See, Java in our classes using Eclipse. Yes, in our daily classes, I'm using Eclipse only here. Okay, just a very simple program using notepad. Yes, very simple program using notepad. D drive test folder. So CMD, command prompt, open command prompt. Yes, here go to D drive. D colon will take to D drive. CLS, clear the screen. So DR, check it. Yes, now go to test directory. Changing to test directory. CD, change of directory. CD, change of directory. Test, change, right? CLS, clear the screen. DR, yes, 0 files. So this folder is empty. Test folder is empty. Test folder is empty. Now let us write simple Java program. Yes, notepad test.java. Notepad test.java. Notepad like a Python scripting here. Test.java program. Yes. Do you want to create new file? Yes. Now simple. Yes. Simple Java program public class test. Public class test. Yes, class starting ending. Right. Next main method. Public static void main. Yes, string square bracket fox string area fox. So main starting ending. Right. Main method. Here's a system dot. Yes, out dot. Yes, println within double quotation. Hello world. Hello world, right? Yes. Hello Java world. Hello world, right? Yeah, this is simple code. Save. Save. This is called a source code. This code is a source code. The program. So this program is source code. Save it. Save the source code. Yes, command prompt. Here, check it. See that. Test.java file. Right? Test.java is source code file. Okay, just now created. Now comparison. Java C means Java compiler. Java C test.java. Right? Compiled. No errors. Java C test.java. Java C means compiler. Java compiler. Test.java. The source code compiled by the compiler generated some result file. Yes. DR, check it here. CLS, DR, check it. See dot plus file generated. Simply dot plus file generated. Okay. Yes, let me repeat once again. Del star dot class. Dot class file deleted. CLS. Okay. Now here Java C test.java compiled. After compilation, now check it here. Dot class file generated. Result of compile is dot class. Dot class is a byte code file. Dot class is a binary code different, byte code different. Dot class is a byte code file. It's a byte code file. Byte code file, right? So what is happened here? Yes. So first test.java, right? Test.java. Yes, it's a source code. Test.java is a source code file, right? Yeah, the source code file taken by Java compiler. Java compiler, right? Yes. Test.java given to Java compiler, right? Compilation, if no errors, generating dot class file. So dot class file is a byte code file. Yes, it's a byte code file. Yes, it's a byte code file. So that byte code file generated. Simply bytecode file generated. Okay. Yes. So test.java taken by Java compiler, no errors, generated dot class file. So dot class is a bytecode file. Dot class file is a bytecode file. Right? Dot class file, right? Dot class file. Now let us run it. Java test. Java test. Run it here. Yes, executed. Hello Java world, right? So what is Java? So you get Java C means Java compiler. Java C means Java compiler. Here Java means what? It's interpreter. Java interpreter. The dot class file. Dot class means bytecode file. That bytecode file taken by Java interpreter then executed. That bytecode file taken by Java interpreter and executed. So dot class file. Yes, this is taken by Java interpreter. Java interpreter. Okay, right? Yes, after taking by Java interpreter, yes, simply converting into binary format. Binary code. Okay, binary code. After converting to binary code given to processor. And processor. Simply processor generating output. That's it here. Okay. So here it says Java interpreter taking bytecode. Bytecode given to Java interpreter. Yes, converting into binary format line by line. And given to process then execute. First line converting and executing. Next line converting, executing. That result will not store anywhere. See Java interpreter, yes, it's interpreter. It won't generate an exe file. No exe file. Yes, bytecode dot class file taking with Java interpreter, converting into binary format, line by line, convert into binary format and given to processor. Next line convert into binary format, then given to processor. So conversion, then execution, right? So this is what is happening in Java. So here, right? Yes, what is happening here? Yes, in Java errors checking by the compiler. Java errors checking by the compiler. In Java errors checking by the compiler. If no errors, yes, then generates dot class file. Then generates dot class file. Generates dot class file. Generates dot class file, right? Yes, in Java, first of all, errors checking by the compiler. If no errors, generates dot class file. Dot class file, right? Yes, next dot class file. Yes, executing by the interpreter. Dot class file executing. Yes, executing by the interpreter, right? By the interpreter. Dot class file. Yes, executing by the interpreter. So what is happening here? So errors checking by the compiler, but runtime execution by the interpreter. So what is happening here? So these two things are involving compiler, interpreter, both are involving. So first step, source code to bytecode by Java compiler, bytecode to binary code by Java interpreter. So these two things are involving, right? Compiler and interpreter both are involving. Then what is Java? Is it compiler based or interpreter based? Tell me now, guys. What you understand? Compiler based or interpreter based? Both are involving. Suppose C language only compile involves. Okay. Python only interpreter involves. But when come to Java, yes, involving both. So Java depends on both. Here. Java, yes. Is Java compiler based or interpreter based? Both. It depends on both. Right? Java depends on both compiler as well as interpreter. Java depends on both. Okay. So Java, yes, depends. Java depends on both. Both compiler, yes, as well as interpreter. Both compiler, yes, as well as interpreter. Depends on both. Interpreter, right? So Java depends on both compiler as well as interpreter. Errors checking by the compiler, but program execution by the interpreter. So two things involving. So this depends on both. That's it. Now, some question for you guys. Can we create? Yes, it's a interview question. Can we create exe file? Yes, can we create
Sir,
exe?
I have a small doubt.
Yeah, tell me.
So to converting source code to bytecode, I thought we use compiler, sir.
Yes, compiler, 100%. Source code to byte.
Yeah, but
No.
you written as interpreter.
Interpreter, very such.
Yeah, bytecode to binary.
Source code to byte code by the Java
Okay.
compiler.
Okay.
Byte code
Okay.
to binary code by Java interpreter.
Okay.
Clear a byte code to binary code by Java interpreter. Okay. Source code to byte code by the Java compiler. Yes. Byte code to binary code by Java interpreter. Even step by step. First test.java source code. Java compiler. Generated dot class. Byte code, right? That byte code taken by Java interpreter. Converting into binary code. Given to process. So finally generating output. That's it here. Clear up? Yes. So source code to byte code by the Java compiler, source code to byte code by Java compiler, byte code to binary code by the Java interpreter. Right? Two things are involving. So Java depends on both the compiler as well as interpreter. Now question is here, can we create exe file in Java? Can we create exe file in Java? See in this process, .java .class, right? No .exe. Java don't have .exe file. Everything is .class file. Dot class is not exe. Exe different. Yes, dot class is different here. No. Can we create exe file in Java? No. No. See, in Java, yes, exe file concept. Exe file concept. Yes, was removed to make it as independent platform. Exe file concept removed. Yes, to make it as independent platform. Yes, independent platform. See, wherever exe file concept is a platform dependent. Okay. Yes, about exe next session. Exe file dot class file differences. Exe file is a platform dependent. Dot class file is independent of platform. Reasons next session I will explain very clearly. Yes. In Java, exe file concept was removed to make it as independent of platform. Okay. So exe file is not a dot class file. In Java, everything is dot class file. In Java everything. Yes. Java everything is a dot class. One second. Hello. చెప్పండి క్లాస్ లో ఉన్నాను చెప్పు చెప్పు అదేలే క్లాస్ లో ఉన్న వాళ్ళకి ఫోన్ చేస్తారండి ఎస్ జావా in Java. So everything is a dot class file. Dot class file. But dot class is not exe file. So dot class is different. Exe file is different here. Dot class file, yes, is not an exe file. Is not an exe file. Dot class file is not an exe file. So what is the difference between exe file dot class file? Next I will explain. Okay. So exe file is a binary code file. Exe file is a binary code. Binary code file. Okay. And it's a system understandable language. It is a system understandable language. System is understandable. System understandable language. Okay, system understandable language, right? Yes, exe file. Exe file is a binary code file. It's a system understandable language. So when you come to dot class file. So dot class file is a byte code file. Dot class is a byte code file. Dot class is a byte code file. And it's a JVM understandable language. Dot class file understanding with system don't know about dot class file. Dot class file. Yes, it is a JVM understandable language. JVM understandable language. Right? JVM understandable language. So JVM taking dot class file, converting to binary format and executing simply here. Okay. So exe file is a binary code file and it's a system understandable language. Dot class a byte code file and it's a JVM understandable. JVM understandable language. Understandable language, right? Yes, next one more thing. Exe file. Exe file. Yes, exe file is a platform dependent or OS dependent. Exe file is a OS operating system dependent. Reason next session I will explain. Exe file is a OS dependent. Okay. Yes, dot class file. Yes. Dot class file. Dot class file, yes, is an independent of OS. So the reasons next session I'll explain here. Okay, so here main reason here, exe file contains OS library. Dot class file don't have OS library. Exe file contains OS library. Dot class file contains no OS library. Practically I'll show in next session. So why exe file is OS dependent? Suppose C and C++ exe files are OS dependent. Java dot class file independent of OS. That reasons tomorrow I'll explain here. Okay, exe file case. So OS library statically linking dot class file. OS library linking dynamically. Yes, just only hint given. Tomorrow I'll clear that. What is statical linking? What is dynamic linking? That concept next session I'll explain. Yes, almost 1 hour session that is. Very interesting session, 1 hour session. Yeah. So that's all about, yes, interpreter compiler. So Java depends on both. Java depends on both, right? Interpreter as well as compiler. Java depends on both interpreter as well as compiler. I hope you understand, guys. Yes. Let us go to document here. Your class document. Yes. So that yesterday's document. Yesterday document. See, every topic very clearly prepared in document. Step by step. Nothing missing. Yes, you guys even not necessary to write any running notes. Okay. Not only this theory part here, even coding also prepared already. Coding. See this coding like this. See this. Here coding. The code. Complete code. Even very big programs also prepare the real-time use cases, scenarios. So this is some link, a realistic concept. Yes, collections and DSA concept. That including memory map. How is storing in memory programs. Yes, more than 300 programs are there. In total core Java, more than 300 programs I have prepared in document. It's very simple and easy to learn. Yeah, this document very useful for us. Very useful document. Just you can follow document here. Just you follow document here. Yesterday and today topic. Every point it's there in document here. Even single line is not missed. See difference between compiler and interpreter compiler, interpreter line by line, compiler whole program at a time, interpreter line by line result. Yes, compiler at a time. Yes, interpreter. If any error occurs, interpreter stops. Only one error. Compiler, all the errors from top to bottom. Yes, interpreter, no. Yes, not generate exe file. Yes, it generates exe file. It executes source code, it executes exe file. See, interpreter, these are called as scripting language, compiler, programming language. See examples. Same. Every point is in document here. Just you can follow document here. See about Java. Java depends on both compiler as well as interpreter. Compiler and interpreter. See this. Source code to byte code to binary code. Right? Yes. Source code to byte code by the compiler, byte code to binary code by interpreter. Same. The steps, right? So whatever things expanded, same thing is there in document here. Same. Okay, right? Yes. So Java bytecode was introduced to make it as independent platform. So Java depends on both compiler, interpreter, right? Yes. Can we create exe file in Java? No. There is no concept of exe files in Java. In Java, everything is a dot class file. Everything is dot class file. Dot class file is not an exe file. Exe file is a binary code file and it is a processor understandable language, system understandable. Dot class file is a byte code file. It's a JVM understandable language. See, exe file is a OS dependent. Dot class file is independent of OS. Yes, exe file dot class file. Yes, about exe file dot class. Here is differences. Next session I'll explain. Next session we'll discuss. 1 second. Tomorrow session, Java installation. Yes, how to install JDK. Yes, Java 17. Tomorrow topic, Java installation. how to install Java, how to set up Eclipse, and all that I'll explain. Tomorrow going for the first program. Okay, once first program finished, then you can understand about independent of platform, portability, and all that features. Okay. Yes, I'll give the drive access. Okay. Yes. I think some students already have paid. I'll take the paid emails from the online team. Okay. Yes, all paid emails I'll take from online team. Yes, today night I'll give the drive access. So by the time of before starting class, we'll get the drive access. So download all the software. So whatever the access given here, just you download yes Java software. On recordings you can watch it and everything will be created. Yes, I'll create one drive, keeping into your drive. Yes, that drive I'll share with you. Okay. Yes, after sharing, how to access your drive, that topic tomorrow I'll explain. Tomorrow, right? So today, yes, once the class finished here, I'll create drive now. After creating drive, yes, all videos, I think 4 sessions completed. All the 4 sessions I'll keep into drive. Next, Java software also keeping into drive. For example, here is like this, the previous batches drive. Yes, drive will be like this. Yes, I'll give the access to the drive. For example, either 7 o'clock match. 7 o'clock match. Yeah, this is drive. So these are all the recordings. All that recordings, documentation, JDK, Eclipse, and our daily class document. This is 900 page document. Okay, I'll give the drive access. Like that, for your batch also, I'm creating drive. Next, one more interesting one. The 7 o'clock batch also merging into your batch only. 8:15. The 7 o'clock already 15 members are there. Your batch and that batch maybe 25. I think it will be definitely 25 members batch. It's a good batch, no doubt. Okay, right? Yes. So I'll give the drive access to all paid students. Yes, I'll take email IDs from the online team. I'll give the drive access. Right? Yes, so tomorrow it's a paid link. Your demo is completed and our request today extended. But actually management not allowed. But I have given chance one more day. Yes, I have requested management. So one more day extended. So demo is completed. From tomorrow it will be paid link. Right here. That's all for today. So tomorrow Java installation live I'll show. I'll take one of our systems. I'll set up in your system only directly. Okay. I'll take one of your systems. Yes, you have to share your screen. Then I'll show in your system directly. Live explanation simply. Yeah, that's all for today. Any doubts? Any doubts? Yes, if no doubts, let us wind up session for today. Right? So thank you guys. Yes, see you tomorrow. Have a great night. See you tomorrow. Thank you.